On the red surface of Mars, within the cold, barren landscape of Jezero Crater, NASA's Perseverance rover has drilled and sealed a rock sample that could potentially carry the secrets of ancient life forms. As scientists on Earth eagerly await the return of this sample, the question lingers: did life begin twice in our solar system? As NASA's Perseverance rover landed on the dusty surface of Mars in February 2021, it embarked on a mission that could redefine our understanding of life beyond Earth. Tasked with exploring the ancient lakebed of Jezero Crater, this robotic scientist is not just searching for evidence of past life, but also collecting and caching samples of Martian rock and soil. The choice of Jezero Crater was strategic. Billions of years ago, this site was a flourishing lake, surrounded by rivers that deposited sediments and potentially organic compounds necessary for life. This geological history makes Jezero a prime spot to look for biosignatures of ancient microbial life. Perseverance, equipped with a suite of scientific tools, including 23 cameras, 2 microphones, and a robust sampling system, has drilled into Martian rocks to collect core samples. These are meticulously sealed in titanium tubes, a method ensuring the most pristine conditions for later analysis back on Earth. Dr. Luther Beagle from JPL stated, "We've designed the rover to operate like a field geologist and a biochemist, highlighting the dual scientific approach in handling the Martian terrain and potential biosignatures." The drilling process itself is a marvel of engineering precision, involving rotary percussive drilling to penetrate the rock's surface, then extracting a core sample about the size of a piece of chalk. The anticipation in the scientific community is palpable, as these rock cores might not just tell us about the geology of Mars, but also confirm whether life once existed there. Early discoveries, like organic molecules found in a sample nicknamed Rochette, built a foundation of excitement. Dr. Katie Stack Morgan, the deputy project scientist, remarked, "Finding these concentrations is what drives us. They are the potential markers of past life. But a more recent sample has generated even greater interest. With a potential biosignature now encased within a titanium tube, the scientific community stands on the brink of a possible breakthrough. This mission, combining robust geological research with cutting-edge technology, may not just rewrite the history of Mars. It could reshape our understanding of life in the cosmos. As we continue to monitor Perseverance's journey across the Martian surface, each sample it collects adds a new piece to the puzzle, potentially bringing us closer to answering the age-old question: are we alone in the universe? Within an area nicknamed Sapphire Canyon, Perseverance collected a rock core that might hold the blueprint of Martian life. In July of 2024, the rover used its drill to extract a core from an outcrop called Cheyava Falls, a sample that now stands out for its unique geological and chemical properties. The rock shows clear stratification, suggesting historical layering of sediment, a process typically associated with water and a critical marker in the search for past life. The core from Cheyava Falls is rich in hydrated silica, a mineral known on Earth for its incredible ability to preserve biological material over geological timescales. This finding, detected by Perseverance's SHERLOC instrument, is pivotal. Hydrated silica could have entombed ancient Martian microbes, protecting them from harsh radiation and chemical decay. Even more compellingly, the sample contains phosphates and specific minerals like vivianite and greigite, compounds which on Earth are often associated with microbial activity in water-rich environments. Recent analysis has revealed microstructures within the silica that, while not proof of life, are intriguing because they share some textural similarities with microbial mats found on Earth. Confirming a biological origin for these is not straightforward. The limitations of rover-based instruments mean that while they can detect promising shapes and chemicals, they cannot definitively prove life created them. These instruments, advanced as they are, simply cannot match the analytical power of full-scale laboratories here on Earth. The potential biosignatures in this rock core include not just mineral deposits, but also complex organic molecules. As project scientist Ken Farley remarked, "While the organics we've detected are intriguing, Without being able to fully reproduce the conditions on Mars in the lab, it's difficult to conclude definitively that they have a biological origin. While the clues of life are embedded in Martian rocks, bringing them back to Earth for conclusive analysis presents an unprecedented engineering challenge. The ambitious Mars Sample Return mission, a joint venture between NASA and the European Space Agency, is the crucial next step. However, the mission's original plan is now under review. Facing significant budget and schedule challenges, NASA is actively seeking innovative and more affordable designs to make this historic retrieval a reality. The anticipation within the scientific community remains high, as Dr. Ellen Stoffen, former chief scientist at NASA, points out. Each sample could be a thread in the larger tapestry of Martian history. Untangling these threads on Earth could finally answer whether life existed beyond our planet. The implications of the Sapphire Canyon core extend beyond mere scientific curiosity. They touch on profound philosophical questions about life's ubiquity and diversity in the cosmos. Each test conducted by Perseverance brings humanity incrementally closer to understanding not just Mars's past, but also the broader narrative of life in the universe. Navigating through the thin Martian atmosphere, a future mission will attempt to retrieve the most valuable cargo ever transported between planets, a possible fossil of alien life. The revised Mars Sample Return mission aims to undertake this monumental task. The objective remains clear: bring back samples collected by the Perseverance rover from Jezero Crater, a site believed to have once been hospitable to life. The original mission concept incorporated a series of high-stakes robotic operations. It involved a fetch rover to retrieve the sample tubes and transfer them to a Mars Ascent Vehicle, or MAV, which would launch them into orbit. An Earth return orbiter would then capture the samples and ferry them back. This complex orbital dance, set to the unpredictable tune of space travel, highlights the immense engineering hurdles. The engineering challenges are immense, and the new mission architecture will need to solve them more efficiently. The MAV, for instance, must be light yet powerful enough to escape Mars's gravity, a pinnacle of rocket engineering. Upon the sample's eventual arrival on Earth, they will be housed in a specially designed biosafety level 4 equivalent containment facility. This will be one of the most secure and sterile environments ever constructed, ensuring any potential Martian biohazards do not pose a threat to Earth's biosphere, while also protecting the samples from terrestrial contamination. NASA's Planetary Protection Officer, Dr. Lisa Pratt, emphasizes the importance of these precautions, stating, "We're bringing these samples back to answer one of humanity's biggest questions. Are we alone in the universe? We must take every precaution to preserve the integrity of the samples, as well as the safety of our planet." The potential discovery carried back from Mars could redefine humanity's place in the cosmos. If these samples contain evidence of past life, it would be the most profound scientific discovery in history, altering our understanding of life in the universe. The Mars Sample Return mission, in whatever form it ultimately takes, stands as a testament to human ingenuity. As we stand on the brink of potentially confirming extraterrestrial life, this mission might not just rewrite the story of life in the cosmos, it could begin an entirely new chapter. As we await the return of these Martian samples, the implications of what they might reveal hang in the balance, potentially proving that life is not unique to Earth and reshaping our search for life in the universe. From a single grain of sediment, we might uncover the vast, untold story of life beyond our world. If you enjoyed this story, hit subscribe for more fascinating historical deep dives every week. Thanks for watching.